Good morning and good afternoon, everyone, wherever you are. It's my privilege to welcome you to this webinar, ARC-Asia Industry Insights webinar. The topic of this webinar is Building Cybersecurity Resilience, Lessons from a Large-Scale Industrial Cyber Attack. Today, we have our eminent speaker, Mr. Justin Na, Cybersecurity Manager, City Power, Power and United Energy. Today's agenda of this webinar, after my welcome note, we'll have event introduction by topic overview by Bob Gill, General Manager, Southeast Asia's ARC Advisory Group. Right after that, we'll have a presentation from Mr. Justin on cyber. He is a cybersecurity manager, City Power, Power and United Energy. Right after that, we'll have a panel discussion between Bob and Justin. Then we'll open up for the Q&A session. We request all of you to please put your questions in the Q&A box so that we can have all the questions, possibilities, and answer all your questions. Now, the topic introduction will be done by Bob Gill. I invite my colleague Bob Gill to do the topic introduction. Over to you, Bob.
Thank you, Rajkumar. Thank you for the introduction and a warm welcome from me here in Singapore to this Asia Industry Insights webinar this month on the topic of industrial cybersecurity. And indeed, this does continue to be a very hot topic. I'm sure you've heard many times about how today's OT systems are inherently more vulnerable with the blurring of the once quite separate IT and OT layers. And also because of external connections to the internet and off-site cloud applications, and from things like valuable but potentially risky practices like enabling remote access into the plant for equipment suppliers and maintenance organizations. But along with these vulnerabilities from system architecture and practices, we are seeing a sharp increase in both the frequency and sophistication of cyber attacks targeting industrial systems, notably including campaigns backed by well-resourced nation states. Now, these are designed to not only disrupt operations like most industrial cyber attacks, but also to undermine national and economic security. So quite serious stuff here. And in this context, we are witnessing the rise of what we call advanced persistent threat groups, or APTs, as the acronym is. And these are often funded by nation states. And crucially, they have the expertise to conduct really quite sophisticated attacks against complex and critical infrastructure. And these APTs have unique and rather interesting names like Electrum, Cyber Avengers, Azurite, Pyroxene, and even there's one called Charming Kitten, which is not actually as cute as it sounds, given it's strongly suspected to be a cyber warfare group linked to Iran's Revolutionary Guards. And it's not really a surprise that since the start of the US-Iran war in February, we are seeing more reports of cyber attacks by the various adversaries associated with that conflict. So in a blog post a couple of weeks ago by my colleague Larry O'Brien from ARC Cybersecurity Research Team, he highlighted an alert from the US Cybersecurity Agency, CSIA, about Iran-affiliated advanced persistent threat actors targeting internet-facing PLCs across several US critical infrastructure sectors. And these resulted in operational disruption and financial loss in at least some cases. And earlier in March, the US medical technology company Stryker, they said a cyber attack, which was actually claimed by the Iranian-backed Handala APT group, they said that this disrupted their order processing, manufacturing, and shipping functions, within their organization. So a lot going on when it comes to nation states and these APT groups. So against this backdrop, I'm really looking forward to today's session, which our guest speaker, Justin Na, will explore this evolving threat landscape by describing a real world and really quite recent nation state level attack over in Europe. And for me, I'm really quite particularly interested to find out, how did these attackers operate? What exactly did they target within the OT environment? What were the affected organizations' inherent vulnerabilities that facilitated the attack? And perhaps most importantly, what lessons can be learned from the incident so that other industrial organizations can better prepare for and respond to advanced threats? So, so right now, let me go from here in Singapore right down to Melbourne in Australia, and let me welcome Justin Na to the webinar and to give your presentation. So, welcome, Justin.
Thanks, Bob. Thanks, Rajkumar. Uh, Good morning, good afternoon, wherever you may be. I'm gonna go and share my screen and we can kick things off. Could I get a thumbs up if everyone can see that slide share?
Yes, Justin, that's fine.
Yes.
Perfect. Excellent. Thanks again, Bob, for the invite to come back and speak to the cohorts here at the ARC webinar. I really appreciate being remembered to come back every now and again, sort of share my thoughts and my learnings, which have been a really good evolution of what I've seen in my career. So to sort of kick off the session, to give you a context of where some of my thoughts are coming from with this particular cyber incident, a bit about myself. Coming up to almost 3 decades now, where I started my career as a control systems engineer. I've been very fortunate to see the technology stack evolve over the past 2.5 to 3 decades, from serial to Ethernet, from using proprietary real-time operating systems to Sun Solaris boxes for engineering workstations to Windows-based machines. I've seen transitions of the dependency to cloud where we have required more compute and more storage capability. I'm staring down the abyss of AI right now as well. So I've had some good views and some thoughts about where we're heading, and I hope to share them with you in this session. I pivoted into cybersecurity during my networks part of my career, and from then on, I look at the overall cybersecurity strategy. I look at the risk management, compliance, and governance. When it comes to my organization, we deliver power distribution to a majority of Victoria down in Australia. So what you're going to be hearing from me, hopefully, is a combination of my experience from the shop floor technical side up to the risk management and up to the executives. I always start with this, and it's called balancing the FUD, right? When you look at cybersecurity as a discipline, there's a lot of sensationalization. As Bob mentioned earlier, even the names are sensationalized. Berserk, Bear, Static Tundra, all these sort of things. There is an element of sensationalization that drives the fear and the curiosity and the black box and the whole mysticism of that. And I think it's a really interesting thing because ultimately, when you look at cybersecurity, you take one element of threat and threat intelligence out of it, it's ultimately about risk management. And in order for us to have better outcomes when you do risk management, you need a clearer head. And definitely FUD isn't one to help with getting a clearer head. I always refer to this particular diagram. I'm sure some of you may have seen this before. It's a description of a plane from World War II. This story apparently is a myth, but the lessons I think are still really relevant. It starts off with the story going that a World War II statistical mathematician called Abraham Wald was asked to look at the Allied bombers that came back and determine how best to armor plate these to make them more resilient. Now, if you put more armor onto a plane, you end up becoming heavier. And the heavier you are, the more fuel you use, which means the shorter turnaround distance you're going to get with a particular bomber plane. So when you look at this plane, I look at cybersecurity in a very similar view. You look at all the dots and you go, you could get shot here, you get shot there. In cybersecurity, you could get things like vulnerability exploits, you could have brute force attacks, you got session hijacking, you got DLL injections. Those are all those white dots. But Abraham Wall was interesting. He said, do you know where we should be focusing on? I'm going to turn on my pointer here. Hopefully y'all can see that. He goes, not in these areas, but in these areas that haven't been hit. The only reason the plane has been able to land back safely for us to analyze is because these areas were not the ones that were hit. And that's where we should be focusing our armoring to increase the resiliency on this plane. Obviously, it would benefit if you could armor here, but the only reason why we've come back to here is because of these particular locations. So hopefully you can see where FUD actually diminishes your ability to assess risk and get to root cause, because if you can't apply the most effective controls. So we'll start with that, and we'll take you through a quick summary of what happened in Poland. So at the end of last year, on the 29th of December, there was an incident that occurred on the electricity grid. Everything that you're going to be hearing from me today are extrapolations of this particular document, which is publicly available. I think the CERT Poland team, which is the Center for Emergency Response, did a really, really good job by analyzing this with their respective partners to provide this report. So it's freely available. There's some really good technical bits in there, but I'm going to try to summarize what happened in this session. So on the 29th of December, a cyber attacker went after predominantly the distributed energy resources, solar and wind farms. 29th of December is an interesting time because it is the time where most people take holidays. And it would also cause the most impact if you were to able to disrupt power supply because it's winter. And it's very clear from what you're going to hear today that they went after both IT and OT infrastructure and did the best they could to ensure that the damage that they caused was permanent and non-recoverable. They targeted at least 30 DERs, solar and wind farms, a singular combined heat and power plant, and a private manufacturing company. The private manufacturing company, there's not too much details on who they were, but they could have just been collateral damage because of the vulnerability that was exploited. Now, focusing on the plane and the part that didn't actually get hit, even though they lost these targets were impacted, they did not lose the ability to generate and transmit electricity safely in Poland. And one of the reasons for that is Poland currently still has sufficient inertia or momentum in the grid. If you imagine your traditional way of generating power, it's usually big spinning machines and turbines, and those things aren't digital. They don't start up instantaneously and they don't shut down instantaneously. So when you have hiccups in the grid, because you have sufficient inertia, you maintain the frequency of the grid, which means you're able to still transmit power and you don't have a blackout or a black start requirement. Now, any other country, though, however, that is potentially going to be more reliant on DER types of technologies, which is predominantly going to be the case in a lot of countries now as we go towards a net zero drive. This is going to be a little bit trickier to manage without the inertia, which means that for us as defenders and for us as designers of these sort of networks, we need to start taking a closer look at how we would secure them better and design them with better resilience. The attribution of who conducted this particular attack was linked to a Russian threat actor group. They come by different names. I think Dragos called them Electrum, Static Tundra is what Cisco called them, Berserk Bears, what CrowdStrike called them. But ultimately, it's a APT group that had an alignment with the Russian government. So for every one of these three scenarios, I'm going to go through how they got in, what they did in terms of elevation of privilege, what they tried to access, how they tried to maintain persistence, and what payloads did they try to dump on these three different types of sites. The commonality across all three was how they got in. It's been disclosed that it came in through an internet-facing unpatched vulnerability on a Fortinet device. There was no CVE. This line here is probably the only thing you're going to get. It's my guess. because back in January 2025, I remember getting a lot of notifications from different threat intelligence groups that a particular vulnerability affecting Fortinet devices, there was a CVE 9.8, was actively being exploited. So I'm just drawing a conclusion here, but ultimately this lines very clearly in a way that it allows authentication bypass to administrative rights through a Node.js WebSocket module. So it has the ability that sort of goes, if this was a vulnerability, all you had to do was exploit it and you'd be in with administrative privileges, which is a pretty bad place to be if you're internet facing. So it's been very clear that it's a Fortinet vulnerability, but we don't know exactly which one. This is my guess. So what we're going to do is take a journey through how they did it in all three sites. I think the most interesting one by far is the solar and wind DER. So I'm going to go through this one in a bit more detail, and the other two I'm just going to take you through a more table view of what happened. So the attack started at what they call the GCP, which is a grid substation, the connection point that steps up the voltage from the solar and wind into the HV side, which is then transmitted across into the grid. If we look at your traditional modern substation right now, this is typically how it would look like. And I've got this from a snapshot on the net and just sort of use this as my template to sort of explain what happened. So you typically in any of these substations, you would have a station bus and you got processor buses going down. You may have servers that run substation automation systems. You will have potentially a HMI or a control panel there. That usually is an Ethernet type of network. Sometimes it's a ring, sometimes it's a star. You'd have two buses, XProt, YProt. You'd have RTUs there. RTUs potentially are connected to their IEDs, which could be protection relays, power meters. They're either connected via modern Ethernet methodologies, or they're using traditional old serial to Ethernet conversions. And further down the bay, you get your PTs, your CTs, your breakers. So in general, this is what you would have as a standard architecture for a lot of substations today. So what happened? We know that they came in via the front door, which was to exploit a Fortinet vulnerability, which is exactly what they did. So it was unpatched and it had remote code execution capabilities, and they got in to get to administrative accounts. To compound the issue, the accounts were not set up with multi-factor authentication. Furthermore, if you look at how we would design and deploy solar and wind farms today, they potentially end up being cookie cutter templated type of designs. One design is just replicated across the board, which also means that potentially one vulnerability, one set of username accounts are the same across the board. So if you get to one, you're likely going to be able to get into the rest through the same methodologies. And that actually is the reason why there was such a quick pace that they got 30 of these in one go. Once they got in, they went to the HMI. It's a microNICA HMI, and they got into it not through brute force or some sort of session hijacking to monitor your screen captures. They got in through a default password. They went further down and looked at the RTUs. There were two types, there's Hitachi and there's a microNICA. They got into both with default passwords. Then they went across to the serial to Ethernet servers, which were Moxas. And they got into those with default passwords. Where they could access the IEDs or the product relays, there were a few of them, which were Hitachi Reliance. They got into those by default passwords. So you sort of go, this whole sensationalization, I was hoping for a bit more, like elevation of privilege and sort of session hijacking and DLL injection. They got into all of these through default passwords. Then on the 29th of December, here's what they did from an automation perspective. They reset the serial to Ethernet converters back to factory defaults, which means that they would go back to its factory default IP management address, which means you could not access them anymore. It also would mean that any serial to Ethernet conversion that used to occur across them would halt. They went into the IEDs for the Hitachi Reliance, deleting system files, and they effectively bricked these devices. They went to the RTUs, and this is an interesting one. For the Hitachi RTU, they got a It was not a fake, it was an actual firmware that they downloaded from their website, but they corrupted the first 240 bytes with 0FFs on the hexadecimal line for 240 bytes and uploaded that into the RTU. And when you rebooted them, it went to an endless loop because it was a corrupt firmware. Effectively, you're breaking the device. For the microNICas, they did the same thing. They went just through a bash command and deleted files, device failure. So you're sort of seeing some slightly different patterns here. They're not going, oh, I'm going to go and figure out whether it's DNP3 on Modbus. I'm going to write into a register. I'm going to open and close these breakers. They're doing the very bare basics. I'm going to break this device in the quickest and fastest way possible. And then they go up to the actual HMI because it's a Windows-based machine kind of things, or an operating system type machine. They just wiped and corrupted the files. The HMIs that were not using default passwords were not affected. So all of a sudden, you just realize that even just changing the password tremendously. And on the way out, they went, I'm going to reset the 40K VPN as well, which means that you drop all comms. So you can't actually even restore unless you get to site. To restore some of these devices, you'll probably need a factory RMA to get them sent back to be reflashing. Notice how comms to do all of these on the way out, because if you actually deleted or misconfigured one of these particular, sort of see what they were doing, right? They went for everything that they could to cause the most damage in the least amount of effort possible. So that's a very interesting thing I hope you can take away from the actual DER side. When we look at the combined heat and power plant, it's going to be more of an IT attack. So they came in via the actual FortiGate vulnerability as well. It was detected to the EDR that there was actually long-term infiltration, that they were in there for quite a bit of time without being detected. They did your typical stuff that you would do in any sort of IT place. You look at doing reconnaissance, you do elevation of privilege, you try to get credentials. There were static accounts, and there was no MFA for these critical accounts. Once in, you could use also different methods, Kerberos, LSAS dumps to get the credentials. And even though they were detected by the EDR tool, for some reason, there was not a sufficient incident response to be able to do proper forensics to make sure that everything was investigated, that the threat was no longer present in the network, because they were there for a long time. They did a lot of different things to maintain privilege, to maintain persistence so they could come back any particular point in time. But the one thing that I want you to take away from this, while they're in, a lot of these things that you see up here are pretty much your standard bread and butter. You follow the MITRE attack framework. This is what you would typically do. But for this one here, they were looking for a lot of information with regards to control systems. They were looking for the word SCADA. They were probably looking for words for OT, ICS. They actually know that there is value now for schematics and information about your control systems. Whether you got your control logic sitting in some of these things, they are after that. So they're not after passwords or financial information, they're after your control system schema information. And they downloaded a malware, which is because this is more an enterprise environment, it's going to be about wiping stuff. And on the 29th, they did the same thing. They came back in and they tried to wipe everything, stage from the domain controller through GPO changes. And now their EDR, which is their endpoint detection and response solution, did block these particular malwares. There's no indication about the amount of damage that was caused or whether there was any. I'm quite sure that the attacker didn't get to where they needed to, because on the same day, they made another attempt to come back in to try to load a different version of it, hopefully try to bypass the EDR most likely. For anything that was storage, they try to make sure that they wipe the RAID arrays or to corrupt the RAID configs. And the idea, what you can see they're trying to do here is clear your backups so you have no more backups, corrupt them, and wipe what you currently have. So very, very clean kind of attack path and method, just to make sure they're trying to do as much damage with as little effort as possible. So this was the combined heat and power plant. When you look at the manufacturing sector company, there isn't much information about this in detail, but in essence, the first part's very similar. They came in, they were using elevation and privilege, they got domain controller, and they tried to use a different wiper malware. But once again, What they did notice from the logs that the attackers were scrolling and basically scraping through their storage and their probably a OneDrive or SharePoint items looking for information related to OT. And so you sort of understand why would you do that? There's probably money to be made by getting this information to be unsold. The payload was another wiper malware, which they basically downloaded. And I think for the manufacturing company, they were impacted by it. So with that, I'm going to jump into what I would say are the key observations and some of the root cause analysis from this particular case study. I'm going to split them into the three groups as we talked about, the solar and wind DER, the combined heat and power plant, and the manufacturing plant. And across all three, you can see there's a high demand now for remote access. And if you got anything that's facing the internet, whether it's for communications or for access, it's now going to be a wider attack surface for you to manage your risk and to govern for. For all three as well, the FortiGate vulnerability was an unpatched critical vulnerability that was public facing on their internet. You can see that the basics have and still matter. Default passwords, no MFA, reuse of credentials, static credentials. These are usually recipes for disaster because when you have got something that's public internet facing or you're moving towards the cloud, your identity becomes one of your key protection mechanisms. When the attackers were in some of these enterprise things, you could see that they were not detected. They were either flying under the radar because the thresholds were not being tuned well enough, or they're using what the industry calls as living off the land techniques and tactics. Stuff that we would use for IT maintenance, RDP, SSH, maybe running PowerShell scripts. Those would be the ones that they use to fly under the radar and not get detected. That's going to be an issue. But how they come in, they stay in, and they stay in for a long period of time without being detected. And here's one of the things that I really took away from this case study. And it has to do with the fact that they did destructive payloads. They wanted to cause irreversible damage. But when you think about what we talked about the hype, you hear things like Stuxnet, very specific bespoke viruses that or malware infected. These are very complex type of attack methods. You know, it can write DNP protocols, IEC 104, very, very complex, but they take time and knowledge of the environment to really productionize an attack. And ultimately, you want to do the same thing. You want to impact, as a threat actor, the availability and the safety. Didn't what they just did here achieve the same thing by wiping devices and bricking them? And you can do that at scale without having to know anything in details about a particular memory location or a safety interlock on a PLC logic or an RTU logic. So it's changing the element of what they know. And if you go down into individual, you notice that the DER site, they actually almost left no stone unturned. They went for everything they could get to, from the protection relays to the RTUs, to the serial Ethernet converters, to the HMIs, and to the actual access point. They wiped it and they walked off. And the cookie clutter templates are also going to be an issue. In the CHP and the manufacturing plant, you can see that they were looking for OT data. There's an element that we say down here with the Australian Cybersecurity Centre on OT cybersecurity essentials. There's one clause that says OT data is valuable and needs to be protected. Now you can see why that's the case. We also saw that the antiviruses were not very good at detecting stuff when they downloaded those wiper malwares in storage to be able to run them, but the EDR did catch them. So with these things, what could you do pragmatically? So here's some ideas that, we would always recommend organizations look at. If you have an internet-facing vulnerability, that's a now. The traditional way of vulnerability management needs to change, I believe, with OT environments because you can't always patch. We get that. But if it's an internet-facing vulnerability and it's critical and there are known exploits and it's actively being exploited in the wild, you need to start thinking about the now. The rest of it could be the next. There could be things that are never if you're running legacy systems. And for those, you need to put them into more of a secure area and have compensating controls to manage those. So you need to think about that, especially if you have something that's internet facing. Your identity and access is absolutely paramount. You can see over here, right? How they get in, is it secure? Get rid of default passwords, enforce MFA. These are small little things, but you can see the biggest impact on the first part of the case study where if there was a change in the password, they didn't get in and they walk off. Like any other threat actor, any other criminal, they want to make it as easy as possible, get their money and go. If they're in and you're not detecting them and you can't see them, there's an issue with your thresholds and there's an issue with your detection and response with your SOC playbooks. So you start thinking about how if they're flying in under the radar to stay low and slow and remain undetected, you need to start thinking about what you can do to shift your thresholds and have better response and incident triages. Here's an interesting one. I know that some ICS devices now have the ability for you to ensure that the firmware updates are checked with a signature before you load them. If those capabilities are enabled or possible, I would recommend enabling them. It would have prevented a corrupted firmware being put in that has been modified outside the vendor's capability. I always say build defensible architectures, right? IEC 62443, zones and conduits. Treat each zone, each traversal path, each conduit with minimum privilege, and that maintains your ability to also monitor, segregate, and respond in the time of a cybersecurity emergency. One element that I probably won't have sufficient time to talk about is look at what you would do to move from just defensible. Defensible is very cyber related, defend against the bad people, the threat actors. But if you're building critical infrastructure, we do this all the time as engineers, right? What do we do to build more resilient architectures? And there are things that you can do to bridge that gap right now from a cyber perspective. There are two documents here I would encourage you to take a look at. One of them is the Australian Cybersecurity Centre, what they call CI Fortify principles, which is asking you to think about resiliency and the ability to respond and recover from a particular risk or a cyber threat. The other is the Idaho National Labs Cyber Informed Engineering, which is a very engineering methodology of how you would consider cyber as one of the hazards you need to consider when you're building engineering type of solutions. So I'm going to wrap it up and I'll take some questions from the audience. Hopefully, this is going to be able to sort of summarize what you heard rapidly in the last 20 minutes or so. You're looking at a combined attack where they come in, they spend time, 9 months before they choose a date to basically do a synchronized attack across the board, right? There's also high interest in OT documentation. So you sort of go, why? Well, what would they do with it? Are they going to attack it? So we need to start thinking about how the actors and intent have changed. Although the APT group is aligned to Russian state actors, potentially, or maybe a nation states, they are not the only actors. And for us to think that we may not be of an interest to a nation state, I think what we got to do is follow the money. These APT groups are predominantly acting as ransomware as a service organizations. They align with nation states because it's where they get a source of money from. So why are they getting OT documentation? Why are they exploiting vulnerabilities to get in? Because there is money involved that they can sell what they found. They're not necessarily keen or interested to attack you, but they're harvesting information. So if you have a critical public internet-facing vulnerability, it doesn't matter whether you are a target or not, you are now fair game for the ransomware group. The basics, identity and vulnerability management matter, right? Tune your security operations center detection thresholds to your tooling and your response playbook to handle living off the land. Hopefully, I explained that quite clearly earlier that what I feel is that the price of admission to doing an OT cybersecurity effective attack has been reduced. They're not now thinking about what memory location, does this turn on a particular process or a pump or open a valve. They're going to go, if I wipe and brick these devices, I effectively achieve what I set out to achieve, an impact to the availability and safety. So what you're seeing here right now is an interesting one where it is actually being simplified to get a very similar outcome. And so I'm going to leave you with this. apart from the basics above that you need to think about as you're building stuff, it's got to be defensible and survivable. You got to engage your engineers in this conversation because a lot of things that we're building now with newer technologies are likely going to be more brittle and there's a lot more interdependency. So always design for resiliency, make sure that you manage the risk and stay away from just the FUD and the excitement that surrounds OT cybersecurity. And with that, Bob, I will
Yeah, thank you.
stop
Thank you,
sharing my
Justin.
screen and
Yeah. Mm.
happy to take questions.
Yeah, so yeah, we're going to expand on some of the things that you've talked about in this very interesting dissection of this cyber attack last December in Poland, and it's good to see we have quite a few questions coming in from the audience. And let me ask a couple that occurred to me while you were talking just now, and I know you talked, one thing you mentioned, I think a couple of times was that companies are not doing the easy stuff, that they could be doing. Maybe they're concentrating more on the more sophisticated things, which they think perhaps are giving them more protection. So I wonder, what are some of the biggest misconceptions that industrial companies have about the cyber threats they face and how to mitigate them? What would you say some of those misconceptions could be?
So, good question, Bob. I think, firstly, I would say that the key misconception I would always try to address is the adoption of the technology and the consequence of the adoption of the technology stack. Now, we've seen that change a lot over the past decade and a half. We talk about convergence as one element.
Hmm.
And the convergence doesn't only link between IT and OT. You're looking at the convergence between the IT side having on-prem and the cloud. You're looking at the AI component coming in. And I think one of the misconceptions is thinking that a ITS kind of solution is the only way to actually manage the risk. When you think
Hmm.
about the convergence, what I think about from an industrial perspective is what is my interdependency on the adjacent zone? So if I have dependency on the cloud or the IT side, the question I would ask is, what happens if I lost that particular zone? If I lost the
Hmm.
internet? And a lot of these things are important when it comes to when I say the misconception. It's not just about a cyber attack, because ultimately, if we're here as engineers and we are looking at an industrial site, we're here to ensure that the availability and safety are maintained.
Hmm.
We have been doing this
Hmm.
even before cyber became a particular hazard. And that's exactly what
Hmm.
cyber is. It's just another vector that could impact the availability and safety. So one of the
Right.
misconceptions I would say is don't throw that out the window. Everything that we've done from risk assessments in terms of CHAZOPs, LOPA, using functional safety, how we would basically look at the dependencies across zones and different componentry of that, all of that matters because the more resilient you build something, the
Hmm.
easier it actually is going to be to defend. Looking at the defense alone in terms of cybersecurity tooling, it's all important, but
Hmm.
not the misconception of not focusing on the actual resiliency side of what an engineer can do in building something safer and more available. I think that's a missed opportunity.
Hmm. Hmm. Okay. Okay. And I know that I've seen you use this term, which was actually new to me, the term cyber-informed engineering. Could you say a little bit more about this concept, about this approach to cybersecurity?
Yep. So it's probably built on the same thing that I mentioned earlier. It's
Mm,
a engineering approach to cybersecurity as a hazard. It uses the V model. It has, I think, 12 principles in it. It
mm,
talks about things like how you would do a consequence-focused design, layered controls and defenses. One of the terms that I like about it as you go through these principles when you're designing
mm,
something is called planned resilience. And
mm,
it's a really important point in my view because it sort of goes change your perspective from what if to even if. So let's take a non-control system, a non-industrial environment. Let's look at a plane. And if you are an aerospace engineer, asking the question, what if I lost an engine, is not going to be as effective as how do I keep the plane flying, even if I lost one engine. So the same thing as well, when you think about that, it changes the element of not just what happens if a threat actor exploits this vulnerability? What happens if they do session hijack? What happens if they do DLL injection? What happens if they do elevation of privilege? What happens if they do a Kerberos attack? What happens if they do a C2 callback? That's going to be all those dots in the plane. And if you take the plan resilience part, you go, how do I keep this running even if there is a particular incident like this? And that starts to go back to the very foundation base. And that, in a nutshell, is what cyber-informed engineering looks at. It looks at interdependency. It looks at, obviously, the cybersecurity side in terms of active defense, but it looks at the engineered controls, which engineers have put in layers to keep plants safe and available, and how you would combine them together with digital controls in the cybersecurity realm. So it helps to open up the conversation. It's not only just a discipline that you can use that as principles, but I think it's a really good conversation point if you're trying to bring your IT and OT teams together to go, we're actually on the same page. We're trying to get to the same outcome. And it's a conversation about risk. And here's some techniques that you could do to evaluate that. So that's how I would probably start off with using cyber-informed engineering.
That's cyber-informed engineering. Okay, CIE. Okay, and Justin, you're from a very solid automation OT background, which is great to see in this space. And you would be very well aware, as I am, that there's a much larger emphasis and also spending on IT security versus OT security in the industry. So, given that, what kind of skills and resources do you see generally lacking when it comes to industrial OT cybersecurity teams?
Yeah, that's a good question. I think hopefully for some people on the call, if you're an end user and what we're seeing with regards to government pushes and regulatory compliance, we're starting to see hopefully a bit of shift of that spending money across the board, across cybersecurity and IT and OT. So we're seeing that shift there. So I'm really hoping that that changes over time. Now, the problem is, in my view, having a pool of money is better than having no pool of money. But having a pool of money and not knowing what to prioritize it on and where to spend it first is likely going to be the problem, to which your question, I think, sort of is leading my thoughts to. If I were to go down the path about what I think is lacking in terms of skill, I guess one of the things that we always talk about is the term OT itself. From my control systems background, there was no such terminology. It was the control system. OT was a Gartner term, I believe, to just sort of explain to stakeholders and to probably boards, just like what IT is. The challenge, I think, is going to be in terms of bringing up the next generation of OT cybersecurity resources and skills, is if you were a chief information security officer, Bob, and you were a CISO of a company, and I came to meet you, and I said, Bob, I'm an IT cybersecurity professional. You'd probably be thinking in your head, that's great, Justin. So which domain are you an expert in? Is it network security? Is it cloud security? Is it security operations? Is it secure coding? Is it security architecture? Because IT is made of many different components. But right now, if I were to come and see you and say, Bob, I'm an OT cybersecurity expert or professional, you probably go, well, what's my next question? And so the interesting thing I'm finding, especially if we're looking at componentry, like we've got this different, we've got the networks, we've got cloud, etc., on the IT side. But if we look at the different industrial verticals, the control systems and the methodologies that you use, well, not methodology, the control systems and the designs you use in rail would differ likely from an oil and gas plant, would differ from a power generation site, would differ from what I am doing right now with regards to power distribution. They are PLCS control system logic kind of based, but the way that you would do them, the logic would be slightly different. The safety capabilities and nuances would be slightly different. So, for example, your last line of defense in a lot of these oil and gas plants would be a pressure valve or a flare to burn off excess basically material, right? But you would not have a flare on a train. So that knowledge, I think, is really important, because if we had that knowledge come into industrial cybersecurity, I believe then the decisions about what you would protect as your crown jewels would change. Because right now, we say control systems are the crown jewels. Well, which control system? Because they differ from vertical to vertical
Right.
and what they do. So I
Okay.
think that element is really missing in the skill sets and resources. If we are able to uplift, which is sort of why my biases are towards cyber-informed engineering, if you're able to uplift skills from engineering people into there and bring the traditional cybersecurity practitioners on this journey, it really brings a bit of a dovetail to sort of lift up the entire next generation of OT cybersecurity practitioners.
Right. Okay, that's a good point. That's a good point, Justin. Let's go to the audience questions now, and I see some interesting ones coming in. We have one of our audience members today making this point that, as you mentioned, default credentials were found on the devices Hitachi, Micronica, Moxa. So, is there any regulatory body? The question is asking, is there a regulatory body in Poland? But generally, are there regulatory bodies that mandate credential hygiene on such OT devices to prevent this kind of knowledge seeping out?
That's a really good question, and I'm not going to
Mm,
answer from the
right.
Poland
Yeah,
regulatory landscape itself. I
yeah,
probably wouldn't know that.
yeah.
It's quite clear that even if it was, these organizations did not adhere to it. Um,
Mm,
but I would hazard a guess that it probably would not be enforced, and that's why this happened, or there wasn't sufficient governing
right.
oversight onto it. It is
Okay.
definitely a good idea. So, for example, when you think about what we're trying to do in Australia right now, not so much controls, but more from an IoT perspective, they're looking at
Mm,
consumer grade devices being imported, and there's some rulings being put in that they
mm,
should actually be, when you first boot them up, that it will force you to reset the default
right.
credentials, right?
Yeah.
But we're looking at it from the consumer perspective. None of it is even
Mm,
cascading down into automation and controls.
mm,
That still relies on practitioners to make the
right.
right informed decision.
Right. Okay. So it's really up to them to do that rather than a regulatory body to
Correct,
can't
because
really help
ultimately
you. Yeah. Mm,
it's human nature, right? Like what
yeah.
forces me to change something? I would change something when it boots up the first time and says you got to change your password. Now,
Right.
boot up a
Yeah.
PLC. Does it tell you to do that? It doesn't, right? So there's an
Mm,
element where you're looking at regulatory compliance, you're looking at skills from the engineers, but you're also looking at the vendors and the supply chain, making sure that they create better
mm,
products that prompts these things as it goes about.
Okay. We'll take this question from Prakash, who asks, once an attacker compromises one edge device, what controls are most effective in limiting the blast radius, as he calls it, across the DER sites? Uh,
So I'm assuming we're going to be focusing just on the DER side.
well, that's the
And
question. Yeah.
yeah, so I'll take a broader step behind that.
Yeah,
So
sure, sure.
I'll look
Yeah.
at the an ITS perspective. Now,
Right.
usually with a lot of end user compute stuff that's more operating system based, you will run EDRs. And usually, what happens if you detect something that's bad, you're able to quarantine an endpoint at the edge device. So the question is really good that Prakash is asking because you have typically no ability to quarantine these devices. So if you're familiar with the Purdue model, I always say this: the
Mm,
closer you up towards the top of the Purdue model, which is the internet side, the more likely you are to get breached because that's where they come in. The lower you are into the Purdue model, which is you're getting towards the control system layers, the less compatible those environments are going to be with more ITS
mm,
enterprise-based control. So you're not about to install a EDR or endpoint detection response agent on a control system. It's likely not going to be able to accept that. So
mm,
the further down you go, your ability is to actually quarantine. So you need to do two things. You need to detect for an anomaly first, and you need to
mm,
quarantine. And so at that level of the DER, you're probably looking at layer two networks. Potentially, if you're lucky, it's going to be routed. So you got layer three.
mm,
If it's not, most likely it's going to be layer two or flat. You want to be able to isolate them via a network capability. So you're looking at either blocking things off at a switch port itself to isolate a compromised asset, and you
mm,
want to be able to do it via a zone as well, which is going to be your firewall elements. So you're using
Mm.
what they call in 62443, which is zones and conduits. You have two different
Mm.
zones. You have a conduit that goes across. You need to be able
Mm.
to detect if something's gone wrong or something looks anomalous in a particular zone. You want to be able to triage that and investigate that for anomalous traffic. And then if you notice something is bad, you may want to basically either clamp down on the rules of this firewall conduit that says, look, I'm triaging this. I'm not sure whether there's anything major. I'm just going to restrict all traffic except for what's really critical for my plan to run in the interim and see whether anything hits that firewall rule. Now, if something is really bad, you then just cut the entire thing completely from a logical perspective. The firewall, if your
Mm.
firewall's been compromised, I will always encourage this. You go back to your old school method where your playbook needs to have where the physical cables are that go to the trunks of that firewall or that particular zone, and you need to label them either northbound or southbound so that in the very worst case scenario, you need to isolate the blast radius. You can still run out there and unplug the cable.
Mm. Okay, so things can be done to prevent things getting worse then, yeah.
Correct. It's
That's what
just
you're
that it's
saying.
not going to be the same way that you would do it from an IT and enterprise perspective, where the endpoint
Mm.
has a lot more capabilities to accept tools or agents that can
Mm.
completely isolate that particular element. It's a
Mm.
lot harder when it comes to OT or IoT.
Right. A question from Craig, Craig Mackay, is asking, is prevention enough? And how should we think about the last lines of defense? Is this an overlooked investment when it comes to OT security budgets? That's the question from Craig.
I think you hit the nail on the head, Craig. That's why if you get a chance, I recommend do the search on ACSC's CI Fortify. What CI Fortify actually does is basically exactly what you're talking about. The Australian Cybersecurity Centre, ACSC, is requesting critical infrastructure now to look at 5 different steps. Know what you have, maintain up-to-date inventory, to what the Prakash mentioned earlier, identify your OT systems and the isolation points. Can you isolate the points and run independently, which then reduces your interdependency? And to your last point, prove the ability to rebuild the vital OT systems and enabling critical infrastructure if you've lost that particular section completely. Like if you look at the particular case study here, what would you do with those brick devices? It's very unlikely that they're gonna send you a JTAG that you could put to the circuit board and reflash the EEPROM. All of those are going to boxes with an RMA back to the factory for it to get
Mm.
reflashed. So your point around that, I think there isn't sufficient thought process about what would happen at this scale and what your response would be. So part of ACSC CI Fortify is prove your ability to rebuild that, but also they're asking a very specific thing as well. When you look at what they're saying, can you isolate? And they've asked a very specific thing. Where possible, ensure that you can run in an isolated
Mm.
state safely for a period of 3 months. And
Right.
so in the conversation, we asked them, why is it 3 months and not 1 week or 2 weeks or 47 days? Why is it 3 months?
Okay.
And a really good answer came back when we spoke to the
Mm.
ACSC team. They basically said this for a lot of organizations like us, and if you're in critical infrastructure, you probably have business continuity plans. And you go, look, if I've lost that, I could go to pen and paper for about 2 weeks, or I could put bums on seats or drive out into the particular substation in a ute and start to put things back into manual mode and run it manually. So what they want the critical infrastructure industry to think about now is you're not going to run pencil and paper for 3 months. They're trying to get people past that
Mm.
psychological barrier to look beyond your current
Mm.
business continuity and disaster recovery process to go, this is three
Right.
months we're talking about. So they're asking some
Mm.
very interesting things. And if you're following what we're doing down here in terms of regulation, which is a very good first question about regulatory compliance, we
Yeah.
are looking at changes to what we call the Australian SOCI Act, which is the Security of Critical Infrastructure, where they're starting to embed some of these CI Fortify concepts in there.
Mm.
So they're now
Okay.
forcing organizations to think about these things from a resiliency perspective and not just cyber defense.
Right. Okay. So that's the ASSE you said, wasn't it? ASSE.
Yep, CI, it's called
Yeah.
CI
Okay.
Fortify, Critical Infrastructure
Right.
Fortify. If you just do a
Okay.
Google, it will pop up.
All right. Okay. Daniel's making an interesting point here about how the manufacturers, the suppliers of controllers, PLCs, they will tend to recommend their own networking devices over third-party switches. For example, Siemens will recommend Siemens Ethernet switches, and other suppliers will do the same. What are the cybersecurity implications here, if any, Justin?
That's a really good question. And I think
Mm,
I'm going to split it into two different things. That definitely is going to be a really important thing when it comes to what I would call DCS, or distributed control systems, where these are either rebatch products from the com side from different manufacturers,
mm,
because a DCS has got a particular set of controls they want to maintain for the entire ecosystem, liabilities, etc., like an Emerson Delta V or Yokogawa Centum VP, ABB 800XA. But if you're more in the PLC realm, like Siemens, they still would push probably the Siemens Ruggedcom stuff. Um,
mm,
I think here's an interesting thing. I actually don't see an issue with any product that's being used from a tier one. Now, naturally, if it's the same manufacturer, it doesn't really matter because a vulnerability on a PLC will not be the same vulnerability as on a switch. So that I think is something to sort of look at from a complete holistic view. But here's the interesting thing: if you've not seen what's happening with Anthropic and the Mythos preview, is they're starting to be able to have AI discover vulnerabilities. And I always say this, irrespective of the
mm,
brand, like even though earlier we talked about FortiGate, it's not really a Fortinet issue per se. Every single product, I would say that's digital,
mm,
has a vulnerability. What
mm.
sets it apart is whether or not it has been discovered and
Right.
whether or not
Okay.
it can be exploited. So if it hasn't been
Mm,
discovered, you got a bit of security about obscurity. We're seeing that
mm,
change with Anthropic's Cloud Mythos project and the Project Glasswing. So if you want to Google Project Glasswing, uh, have
mm,
a read of it, be as afraid as I am about where the industry is
mm,
going with this. They're going to be able
mm.
to detect
Right.
vulnerabilities a lot quicker.
Mm,
Now,
right.
that leaves us with the control point about if we are to then prevent it from being exploited, what can you do? So you would then probably look at isolating it. And so if I had a switch and a PLC from the same manufacturer, there is a lower likelihood that the same vulnerability will affect both. Now, if it's the worst case scenario that it is a vulnerability that will affect all the different components from a single manufacturer, I
Mm,
would say then at least follow the IEC 62443 concepts of a zone and conduit. At least have a differentiated product at the edge
mm,
of the zone. So at the edge itself, which is not the control system side, which they want to say you have to
mm,
use my product, but at the edge, have a different firewall. They're not
mm.
going to tell you what firewall to use at the edge. So you're going to go, this
Okay.
manufacturing zone one, I'm going to use product
Mm,
X because that's what the vendor says I have to use, because you could have some legal implications if you don't use it.
mm,
You may not get the tech support you
mm,
need if you don't use the product. They'll blame that product. So I can see where there's some risks there. If that's the case and
mm,
you're tied down to it, at least have a differentiated product of the firewall that separates the zone
mm.
up. Then that way
Right.
you have a response plane.
Mm, okay, okay, yeah. Because and also, as you can see in the Q&A, one of our audience members, Gabriel, he did ask or did claim that cyber attackers tend to target Fortinet devices, but that's not something you would agree with.
It,
Everything,
I
they
think
all have
it is
vulnerabilities.
unfortunate. Basically, why they
Yeah,
target it is because you get a published vulnerability.
right.
And there's no reason why tomorrow, if another vulnerability comes up from another edge product, let's say
Mm,
another firewall brand, Cisco, Palo
yeah.
Alto, not say that they're bad, I think they're all tier one products. What you're looking
Oh,
at is here's the
yeah.
challenge. If those, let's say you use a really top tier one product, top of the Gartner Magic Quadrant, let's just say, if tomorrow
Mm,
there's a vulnerability that comes up and it's critical, very similar to the FortiGate
mm,
ones, and the patch exists, the question comes back to the same thing. Whose responsibility is it to apply the patch? It comes back to us as the end user or the
right.
infrastructure manager to plan for that resiliency. I need to bring this down to do the
Okay.
patch. I can't say I can't do that. So there's a bit of
Mm,
responsibility like they always say, cybersecurity
right.
is a shared responsibility. It is unfortunate though that Fortinet have been had a bit of bad rap because they've had a
Mm,
few of these disclosures that
right.
impact them. But it also goes to the
Okay.
point that their product is very popular and is very well used and very well
Mm,
respected. So
right.
it is one of
Sure.
those things that's a bit of
Okay.
a trade-off, right? So I wouldn't say that they are a
Yeah.
poor product. They're definitely not.
Right.
But it comes
Okay.
back to the same thing. They were unlucky enough to have a string of vulnerabilities that were critical, and their product
Mm,
is used at the edge. So
mm,
they become the first prime target.
right.
So that's sort of
Okay.
where I would probably just balance that
Right. Okay.
conversation around the FUD.
Okay. In the interest of time, I'll take this as the last question from our audience. It's from Kamal. He says the attackers here, in the case you describe, were able to sit in secure devices for months without any detection. Could there have been routine checks that could have been done to sniff them out?
I think that there's two things. If you look at the CHP side, there were EDRs, so the endpoint detection response did trigger on some anomalies. I think there's two elements. I would always recommend some sort of a detection capability, but you can see even in the CHP side, there was detection, but there was no response. So I would say yes, detection capability is important, that is suitable for that particular environment, but more importantly, putting a product in without tuning the threshold of detection and having a response, I think we come back simply like alarm management. If we saw that thing happen 10 times, we're just going to go, that's normal. Seen it before. Now, that's going to be the problem. Your product has detected it, but you've gone, it happens all the time. So that curiosity of what you're seeing, they're becoming really smart by living off the land, which means that even if you had a detection technology, you still need to continuously tune it. So have a detection and make sure you tune it. Make sure you have playbooks that triage and respond to these particular anomalies and not just to basically fob them off.
Right. Okay. Thanks, Justin, and thank you for going through all of these questions that came in from audience. And apologies if we couldn't get Justin to answer your particular question. Maybe we'll try and get those offline to you. So for now, let me, before I hand back to my ARC colleague for the closing, I really want to thank you, Justin, for coming back to ARC and giving us your benefits of your vast experience and expertise in this very, very critical area of cybersecurity. And I think it's been a very, very insightful session today. So, but for now, let me thank you and let me hand back to my colleague at ARC India. Thank you.
Thanks, Bob.
Thanks, Bob and Justin. It was a great presentation and discussion. Hi all, and we have an announcement of upcoming physical events. So ARC Asia Industry Insights webinar online, which happened today. So the next announcement will be given at the earliest, maybe in the month of May. So ARC Advisory Group Forum, Asia Forum, we have for the next month from Tokyo, Japan event on 7th July, and Bangalore event is scheduled on 9th and 10th July, and Singapore event is on 27th August. And we have an Europe forum, which is coming up on 4th to 6th May at Spain. And we have just completed our ARC US America Forum, which was completed on 9 to 12 February 2026 at Orlando. So the videos are uploaded in the YouTube, and you can view the videos of the presentation of Orlando Forum. And we would like to thank Justina, Cybersecurity Manager, City Power, PowerCore, and United Energy for participating in the ARC Asia Industry Insights webinar. And it was a great presentation. Thanks, Mr. Justin. We also thank Bob Gill from ARC Advisory Group for moderating the session. And we also like to thank all the delegates for participating in this webinar. Finally, we thank ARC Advisory Group India team for all the logistic support. Thank you all once again. We'll meet you next event. Thank you.